I'm from Speeding Edge, and my background is, I'll give you sort of a background of where I come from. My original intent was to be an airline pilot, but wound up in technology. Started out in Silicon Valley when the Apollo program was being developed, and right out of college I got assigned to design a radio. 7 of them are on the moon right now. I think a couple still work, I'm not sure, but that's where it all started. That's how I wound up in Silicon Valley. I was not where I planned to go, but this is a board that's from the radio that's up on the moon. Printed circuit board technology wasn't very elegant back then. I made this by drawing on copper with waterproof ink and then etching it in my kitchen sink and then assembling it on my kitchen table. That's how we prototyped back then. And these astronauts bet their life on what we were doing. That's the amazing thing. Why I wound up doing what I'm doing now is when Apollo ended, we all wound up unemployed. And I would happen to be in Silicon Valley as it began to be Silicon Valley, and was asked to design some logic circuits, which was not what I had studied in college. And so, like most of us, we reinvented ourselves, and I went to the library and got some books and studied up and switched and wound up designing test equipment for ICs. As the speed went up, they got fast enough that transmission line management was necessary. I happened to know how to do that. So I wound up being the guru for a very long time for high-speed design, and transitioned from there into what I do now, train and consult. But for years and years and years, I and my colleagues designed the boards for Sun and Silicon Graphics and all those people who got their start in the Valley. And I would, from 1982 to 92, I ran a design company. Back then there wasn't CAD tools like Altium, so we made our own. And we had done that for another company, and there was a demand for what we're doing, and so we started our own company. And I guess over 10 years did like 3,000 boards, all of them big ones, because back then that's what it took. Probably the most complex one had 1.5 miles of wire in it. I made the mistake of taking a job at a disk drive company. That turned out to be brutal, because anyone who's around those knows that the product life of a disk drive is 9 months, and your reward for a good drive is you got to make another one, and another one, and another one. That after a while got tiresome, so I made an attempt to retire. Didn't work. A friend of mine who knew I wasn't working was VP of engineering at 3Com, and says, "I want you to come work for me." "No, I don't want a job. Oh, pestered me. And finally, he says, he sent me a PO for some consulting. And so a really good term, so I went there and I said, "What do you want me to do?" He says, "Well, sit in the cube next to me and tell me what's wrong." Well, that's how I got into the networking business. I did 5 years with 3Com, I guess, through their best years. And during that's when I developed the courses that you see me teach in seminars. And at the end of that's when I made one more attempt to retire. Didn't work again, so we started a company called Speeding Edge, which you see all over the place. And we do seminars all over the world. We've written books. So my life these days is consulting and seminars. And people ask me why I don't retire. What's more fun than this? What's more fun than designing new stuff? I don't know what the next phone call is going to ask me to do. And so being terrible at golf, this is what I do now. And of course the teaching part, it may be the best, because when you see a young engineer get something and the light goes on in there, that's a reward all by itself. And as long as there are people who want me to do that, I'll just keep doing it. So I don't have a retirement plan. I suppose that if you want to say there is one, it's when the phone quits ringing. Why stop?
What is it that makes you passionate about creating?
Well, I guess what makes me passionate is you get to invent things, and most of them someone gets some value out of. Not so sure about some of the stuff we're doing right now, but I talked at an earlier conversation about making the little gadget that you put your finger in that measures your pulse rate. That was a student project in university that I didn't think would be what it is now. But every now and then I work on something like that that really matters. And so I would say 2 out of 3 probably don't qualify like that. But you don't need one very often to keep you going.
So you've been in the industry for a long time. I'm sure you have seen a lot of things. What kind of changed? I mean, obviously that many things changed, but how was your perception of things then and things now?
Well, my early career was logic made from discrete transistors, which meant that you didn't get many flip-flops on a board, 1 or 2. And so watching the evolution of integrated circuits to allow you to make more and more things on one die has been an amazing trip. It's still going too. And to think about someone who has a smartphone in their pocket has more computing power than the biggest computer Cray ever made. Actually, when you move your computer from horizontal to vertical and it flips the picture, that calculation is more than a Cray 3 could do. And you say it's only a phone. Or you complain because the battery runs down in one day. I just don't know what someone is going to come up with tomorrow that is going to be the next big thing. Probably not hardware. But applications. We've got hardware that outruns every one of us right now. I mean, it's kind of, Apple has that crossroads right this minute, is the appeal of adding more stuff isn't causing people to buy more phones like it used to, because the next thing has already got, what they got right now has already got more than they know what to do with. So it's apps, I guess, and if I were to guess, it's things that have to do with artificial intelligence.
From what I observe, there is so many potential technologies coming up now in silos, such as, we got 5G, the next network. Then we have the blockchain coming up. We have Internet of Things, and they're all we have self-driving cars, artificial intelligence, and to me it looks like they are now still in silos, waiting to snap together. What is your take on the future and seeing all these things emerge?
Well, I think we've got a ways to go before we get this stuff all integrated, and I think we're going to discover that some of it we went too far. I'm already seeing that, where you see people angry because of Siri and those little boxes you talk to that they're being eavesdropped on in their home, and Google admits it. We listen to a lot of conversations, and their rationale is that it will help them improve their speech recognition, but it's only a small step to where it's just plain old spying. So we are at a crossroads right now. We got enough of this stuff. We're at risk of not using it right. Self-driving cars are like that. Phones are like that. We really don't have any privacy anymore, and I think we're going to see a backlash for a while, where people start unplugging until they have some control over that. You might say, well, gee, we're not the young generation, and that's true, but we use all this stuff. It's actually been a godsend to my friends who are retired, who had nothing to do. Give them a computer, and boy, you just can't get them away from it. Look at what I can find. That is probably the best thing that has happened at all, is access to information. So that's the good part of all this. But we're seeing backlash right now, and I suspect that's got to settle out for what you talked about, where this stuff starts to be, if you want to call it, integrated. I think we got enough technology to do what we need to do. We just need to learn how to use it. And to be honest, I think we're not doing a very good job.
That you brought that up, I just read an article recently that talks about deep fakes. I don't know if you heard about deep fakes, but it's
Oh yes, oh
video-
yeah, oh yes,
video
yes,
content
yeah.
where another person could talk, and the system would analyze their facial expressions and would apply that sound and the facial expressions to a celebrity like a president. And they're competing against each other, like those research companies, always picking out, hey, I saw that mistake, maybe a twitch in the face or something.
Mhm.
So they would immediately correct it, and that would just immediately get corrected.
Mhm.
And now it gets so good that you cannot distinguish a real Obama from a fake Obama. So they're really worried about the 2020 elections, and that there's going to be.
Oh, I agree. That's
And
scary.
you can even abuse that, in very threatening things like North Korea situations, or I can see that.
Yeah, we have a lot of risk right now because of that. And that's all the computer graphics processing that is allowing that to happen. And of course, I spent like 20 years working on 3D graphic workstations and equipment like that, so we can make animated movies. And now it's gone to what you're talking about, where you can't really trust anything you see right now. You really can't. I don't know how we deal with that.
So let's look a little bit at the new generation of engineers coming up. How do you see? What advice would you give to students that just came out of university or are still in university, and then would make them aware of getting prepared for their careers?
It's interesting, good ask, because I started a program at my university to deal with that very subject. Because all tech companies, the ideas come from the techies who start the companies, and as time goes by, they get the idea that they don't know how to manage. And so there is this notion that there's something called a professional manager, which is not true. And if they relinquish control of the company to somebody, they don't have the vision, and invariably those companies go away. The thing I'm sponsoring is what I call a leadership program, where it's an extracurricular program where they learn to lead, learn to resolve conflicts, learn to make presentations, because if you look around the companies that are long-term successful, they all look like that. They like Hewlett and Packard did not give up leadership. They surround themselves with people for the skills they didn't have, like sales and marketing and accounting. The same is true for Microsoft, Google, all the ones that are long-term successful. The techies who start it stay in charge. So my advice is, you're going to be the leader whether you like it or not. So go get an MBA, so you know who you need to surround yourself with. The rest of the company looks at us engineers for guidance. That's what tech companies are. And so my advice is, understand that people expect you to lead. Go get the skills. Go get the skills. And don't be afraid. I can't tell you how many companies I've seen fail because the engineers who started were afraid to be the leaders. Unisys is one that failed because they put a finance guy in charge, which is odd. You would never think about putting an engineer in charge of a bank. Where would you put an accountant in charge of a tech company? Every place I've seen that happen, the company fails. And every time it's because the engineers did not step up. It's not the finance guy didn't want to lead the company, but no one else was doing it. So young engineers, you are the leaders. So I put my money where my mouth is. I sponsored this scholarship program for these kids because I think it's that important.
Is this something that you would tell students that they need to be careful of moving forward with their technology?
Yes. Be careful you don't stop learning, because our industry is not static. I got good news and bad news. The good news is you don't have to keep doing the same thing for 30 years like the postman who goes crazy because he's bored. Bad news is something new you have to do every day, so you have to keep learning. Today I study a day a week, every week, because that's how fast stuff changes. So that, aside from recognize you're the leader, realize you have to keep learning. What you left college with is only the ability to learn and some science. I mean, think about my career. Nothing I do existed when I was in college. Nothing. Not even integrated circuits. So realize you're a leader, realize you got to keep learning. Oh, and the third thing, give back. We don't have enough people doing that. We're not enough people. When I was a young engineer, tech companies were organized like apprenticeships, where you're a new engineer, you didn't work on a critical project until you had been tutored for a year or so. Tektronix called it kiddie engineers. Motorola had another name for it, but you would be given a mentor and a project to do that was not critical to the company, but required you to go do everything in every department of the company. Purchasing and manufacturing and all those things, so you knew who your customers were. Well, that giving back doesn't happen anymore. Startups have killed that. So us who have been there and have something, owe it to the new generation to pass it on. That's part of why I still do seminars.
I can just talk for myself that, as you grow up and you're a student, maybe you're a little bit shy to go to people because you think exactly those people who want to mentor, they're maybe too busy or something.
Mm-hmm.
What would you say to kind of take that worry off of people, of students?
Well, the first thing I guess I would say is ask lots of questions. Don't think your question's dumb. There aren't dumb questions, there are dumb answers. So, and that's a problem engineers have. They're timid. They're afraid they're going to ask the question will make them look stupid. Be brave. Do it. How else does the information get passed on? And the reason for doing, I would say that, is because most of the people who know it are shy about passing it on until you ask them. And like you're seeing right now, once you get them started, you can't stop them. But you got to get them started. You guys are doing something really great here. You're going and finding people with this sort of thing and information and making sure it gets recorded. I think about that a lot. How do I pass this on? I mean, when I'm finally done, it's gone. It's just gone. And I have a perspective almost no one else has, in that I have been designing products where it's imperative that we first build test boards so we know if what we want to do will work. So I've had the luxury of building probably 50 test boards over time to measure, is this really true? How far can we go? Because we all start with a list of things that we don't know. And until you do a test to find out is what somebody told you really true, you got to put it up there as I don't know. And I suppose the hardest part of this whole for me is there are a bunch of people still around who are said to be experts who are repeating things that are wrong. And I think that if you're going to be someone who imparts knowledge, you owe the proof to whoever you say something to. So nothing in my courses is in there if I don't have a proof. And I often say, when somebody says something that doesn't sound quite right, say, I'm from Missouri, you got to show me. I don't know if you're familiar with that saying, but the state of Missouri's motto is the show me state. So if you want me to believe it, you got to show me. And of course, if we're engineers, we're applied scientists. And the underlying principle of science is a theorem is assumed false until demonstrated true. And that bothers me that there are people who put out things that they say are true without any proof and get angry if you challenge them. So if there's no proof, it's not in my rule set. So it's on the back of my business card. Show me the proof. I won't use your rule till you show me the proof. And that's another thing I would ask new engineers. Say you're from Missouri. Don't accept something from someone without a proof. Because there still are a huge number of things out there in circulation that are just downright wrong, represented as being truth. We talked about right angle bends. That's just as wrong as they get. So be a skeptic. Be an applied scientist.
And I think you hit a very good spot today, because nowadays everybody can put up a YouTube video, right?
Yes.
Get a lot of views, and then if it suits you, you write the comment, I like it. And I agree with you, even though it's not true.
Yeah.
And that not only applies to scientific things, but any kind of content.
Oh yeah.
It's unfortunately we need to more and more apply
the skepticism. Yeah. If there's ever a time we need it, it's right now, because of the things we already talked about with the fake videos and so on. You've heard this. Well, it's on the internet. It must be true. It's on the internet. It should be assumed false. Yeah, right?
Yeah, tell me about your nanosecond.
Oh, okay. So when I'm teaching a class to new designers, one of the concepts that they need to get comfortable with is the concept of time versus distance, because that is how we're going to decide if a trace is long or short, or needs to be high speed or not. And so what I have here is how long a nanosecond is in a printed circuit board. It's about 6 inches or 15 centimeters. And I'll give credit where this is due, because I didn't think this up. Admiral Grace Hopper was in charge of the Navy supercomputer program, and the original computer she had was the ENIAC, which was the first real computer, all vacuum cubes, monster thing, 50 feet long. And as the Navy began using the computer just to calculate projectile arcs, and as time went by, they wanted to do more elegant things like flow of fluid over a submarine hull. The programs got complex and they took forever to complete, and the users complained. So she knew the problem was the travel time of signals from one end of the computer to the other was limiting how fast it could go. Well, the Navy brass didn't understand any of that, so she took a 12-inch piece, which is how far an electromagnetic field travels in free space. She said, look, I can't make this thing go faster because it's 50 feet long, it's X number of nanoseconds, and so the clock can't be faster than that. So if you want me to calculate quicker, I got to make the computer smaller. And that's what gave rise to Cray research, because Cray was able to make with transistors a much smaller machine that could clock faster. And there were an evolution of computers after that. So Grace Hopper wrote COBOL. So her real claim to fame is that operating code. But she used this concept to show people how fast something can be if it's a given size. And so if you want to go fast, things have to get smaller and smaller and smaller. The reason that ICs go so fast is the distance between transistors is nanometers. 100% of the speed increase in integrated circuits has come from two things: putting the transistors closer together and make them smaller. And almost all the power consumption has to do with, for me to get this logic line from 0 to 1, I have to charge up all that parasitic capacitance. So I charge it up, and then to get it 0, I discharge it, and that is where the heat is in CMOS. So if I make this shorter, I put less charge on it. So all of the performance, speed improvement, all the power consumption improvement in ICs has to do with getting rid of parasitic capacitance on the connections. I mean, it seems like it should be something else, but that's it. Of course, when the transistor is small, it's also faster. So there you go. So this little printed circuit board right here is what made the iPhone possible. I had been part of a startup called Audio Highway, which preceded iPods and stuff like that, where we were going to make a portable device where you could have music stored on it that didn't involve a tape or CD. And at the time we did that, the memory that was available was not big enough to solve the problem. We had the library and all that stuff went out of business. Well, there was a fellow named John Rubenstein, who was the VP of engineering at Apple at the time, who noticed that Hitachi had come out with this was a 1-inch square disk drive, hard disk drive that had 40 gigabytes on it. So, there it is. There's the storage. So he took this and a little display and made the iPod. Those sold by the millions and millions, and the cash from that paid for the research to develop the iPhone. And hardly anybody knows this, but before John came up with this, Apple was almost at bankruptcy because their market share for computers was so small that they weren't making a profit. A high volume computer was the IBM PC, so all the developers made their stuff run on a PC. Well, Apple was this close to going away when this little guy came along. All the rest is history. That little thing right there saved Apple. They didn't write about that in Steve's book.
Is there another example that you can think of where a company just scratched the curve because of a last-minute innovation, such like that?
Well, I have more examples of companies who disappeared because they failed to grasp what came next. We had an era with mini computers. There were probably half a dozen companies that made those, and they all ran Unix, and that was the kind of computer that manufacturing used to do inventory control and all that sort of thing. A little thing called a Sun workstation came along that allowed somebody to do all these things on the workstation and not need the mini computer. Well, everyone in the mini computer business didn't catch on that. Data General, there's probably 7 or 8 of them that were all dependent on the mini computer market, and the workstation made them obsolete. So every single one of those companies just disappeared. I know about this because we were in Silicon Valley designing boards for the workstations, Sun and Silicon Graphics. And because we were doing that, companies like DEC, we had them as a client, and Data General and IBM and Unisys all contract with us to have them show us how they could hook workstations to their mainframes. And so we had a hard time explaining to these people that if I have a workstation, I don't need your mini computer. 3 of them launched programs to develop workstations too late. DEC did, Data General did, and Unisys did. But they all were too late, and they're gone. So they missed the boat. Well, 2/3 of the IC companies missed the boat and are gone because early ICs were all bipolar transistors, ECL or TTL, and neither one of those scale very well. And ECL's problem was it's fast, but it uses a huge amount of power, and so you couldn't, without causing heat problem, make big chips. And so the companies that were committed to those technologies chose not to embrace CMOS, which is all there is now, and every one of those companies is gone. All of them. Every single one of them. And of course, you can say that about some of the networking companies too. That's 3Com. They were ahead of Cisco with routers and switches, but the market was just really starting to grow. At the time, if you wanted to hook your PC to the network, you had to get a network interface card that plugged into a slot. 3Com had a division that sold network interface cards, and they were selling them by the million, literally. and got so committed to that they were spending all the profits on that, ignoring switches and routers. So the switch and router guys, in frustration, moved to a little company called Juniper Networks. 3Com stuck with network interface cards, which became integrated on the motherboard. Whole market went away. Whole company went away. Disappeared. I was there, and that was one of the reasons that I did this. I talked about having engineers realize that they got to be leaders. The engineers in the router and switch division were too timid to step up and say, here's what's really happening, folks. And the guys that were doing the network interface cards outshouted them. More than anything, it was watching that caused me to do that scholarship program that I just talked to you about. These guys knew where the market was going and failed to step up to the plate and convince the rest of the company. They knew it. They knew it. And I watched it. I was being a consultant at the time, so I didn't have any say in that whole thing. But I said, this is terrible. These guys were so committed to network interface cards, they built a complete assembly factory in Singapore with 6 assembly lines just in time for them to go obsolete. Never assembled a single card there. There's a saying that describes something like this as snatching defeat from the jaws of victory, which is what they did. I actually have a picture in my mind of a book I'm going to write, which is sayings like that, and under that saying will be the picture of the president of 3Com. Because he took a company that was just killing the market and destroyed it. The Professional Society of Electrical Engineers is the IEEE, Institute of Electrical and Electronic Engineers, and almost no engineers are members, which puzzles me because that's our professional society and that's where the proceedings are, where all this new stuff is published. So one more thing, join. Become an active member of the IEEE. There exists an online library that is everything that's ever been published, papers and so on, at the IEEE that you then have access to do research. And the engineers don't belong to the IEEE, so they don't get to look at them. I mean, what is this? You would question a doctor who didn't belong to the AMA. Actually, he couldn't be a doctor who didn't belong to the AMA. What's with our professional society? Why aren't we part of it? And I guess I don't know. I joined as a student.
So my last question is, what is, regardless of engineering or anything, what was the most impactful book that you ever read?
In technical kind, hands down the most impactful is an older book, but it's called Pulse and Digital Circuits by Millman and Taub. And I still have it, and it's still valid because physics is physics, and we just turned up the clock speed. My pet author is Arthur Conan Doyle, Sherlock Holmes. My second pet is Mark Twain. I can read their books more than once. I have. But on the technical side, still Millman and Taub. Number 2 is probably Eric Bogatin's book. What Eric and Larry did was put the stuff I teach down on paper, which is, I'm really happy someone did that. There's another book. It's not the top of my list anymore, but the first book that came out that was so-called high-speed book was by Howard Johnson called Black Magic. I saw the book come out. It says, finally, someone put this stuff down on paper, the basics. When I was at 3Com, for some reason, 3Com hired him to interview the senior engineers. And so when it came my turn, I complimented on writing the book, and I had completely forgotten about, I taught him that stuff. So I didn't remember. And he says, oh, well, here's where I got it. When I was doing that design company, almost every client we got had new engineers who didn't have much experience. The first 2 days was usually a tutorial, and that was true for him. And so when I got all through with that, he just got out of school with a PhD, And when I got all through with that, he says, well, is there any books you can tell me to read? I said, no, there aren't any. So they said, well, what do you use? And I said, well, I have a file cabinet full of about 1,000 research papers that, of course, no one else has access to. So he took that and wrote that book, and I hadn't remembered that where he got it was from that 2-day session that we spent together. So that for a long time was the book I recommended that students buy. But Eric's book has gone way beyond that. It's kind of been wonderful to witness all this happen, to have been able to have a career that spans all this evolution from vacuum tubes to where we are now. Special position to be in.
Thank you very much.
Oh, my pleasure.